Okay, I'm live. All right, guys, we don't have a whole lot more to cover in terms of like covering the material. I'll have a bunch of time in class to work today. Let's finish doing that example. So there's no confusion.
But this is not Arkansas.
What?
Well, this one Kansas, but this is not Arkansas. America, explain.
No. Wow. All right. So the one we started yesterday, we got kind of cut short. Here's the ground. Here's the vector. It's 50 meters per second, which means that, so what you got to do is think about this as 25 meters per second horizontally. So that's like kind of like your Vx, at least your Vx initial. And then your Vy initial, again, this is just the initial speed, is 43.3, not 43 and a third. 25 root 3. 25 root 3 if you want an exact number. Yeah, guys, and also, yeah, don't forget, I mean, this stuff is certainly still a thing. The fact that if this is 45 degrees, then if this was V, this would be V root 2 over 2. This would be V root 2 over 2. And also, just, you know, these things are, obviously, they still exist. Little refresher for you from back in your geometry days, special right triangles. Oh, sorry, this is 30 degrees, of course. And it's 60. Okay. So, you know, that comes up from time to time. Or let's say taking a multiple choice quiz and the answers could be written in that form. Yeah.
No.
Yeah, definitely. I mean, this stuff is something that, this is in the very small set of things on ACT math that you have to like have memorized, basically. There's not much. There's like the Pythagorean theorem, angles of a triangle add up to 180, like maybe what slope is, things like that. But there's not really, you have to know the definitions of sine, cosine, and tangent. But other than that, there's ACT. You don't have to like have a whole bunch of formulas memorized or anything. It's all pretty straightforward. It's all pretty like core ideas. So anyway, how long will it take to reach its maximum height? So just remember, we're using the exact same pair of formulas for every question, or at least that's one way you can approach it. So when will it reach its maximum height? Well, you basically say, I'm only looking at vertical motion here. I'm only looking at vertical motion. And so I'm going to say V final equals V naught plus AT. And so if I'm just concerning myself with vertical motion, V naught is 43.3. Acceleration is negative 9.8. And this is the hardest part for most people is making this click in their head that if I'm just looking at vertical motion, then my vertical velocity component is 0 when I hit the peak. By the way, here's a great question for you. How fast is this thing moving at its maximum height? This is part C, by the way. But you already know the answer to it. It's 25. Because this thing's going to do this, right? Well, let me draw it again. It's going to go, pew. Well, think about what's happening here. When it hits its peak, its vertical velocity, its y component, is 0. And so all that's left over is this constant So the answer to question C, there's not actually any calculation really involved. This is a pure physics question in the sense that you have to just understand what's happening with the motion of those two components. But at the top of its path, its velocity would be just 25. So anyway, let's get back to the part A. So if you solve this, you end up getting 43.3 divided by 9.8. Did someone get that with a calculator? 4.42. Thank you. Okay, so it takes 4.42 seconds to reach its max height. So then for part B, we ask the question, well, how high did he actually go? You have basically, there's more than two options here. But really, there's two simple options. One is just plug that time into the position function. That's probably the most straightforward way. The other way that I'm thinking of would be to use some argument about average speed. We can confirm both. So let's do the basic method where you say, my formula for position is y equals y naught plus v naught t plus 1/2 at squared. Let's put in everything we know. Initial y value is 0. Initial velocity, again, we're talking about vertical only. It's 43.3. So my initial velocity in the vertical direction, by the way, why am I only looking at vertical motion? The question's asking how high. The question's asking about a y value. So this would be 43.3 times 4.42 plus 1/2 times negative 9.8 times 4.42 squared. Does everyone understand this? And of course, the y value that I'm looking for is the maximum y value, y max. So Mr. Calculator comes in here. Did anyone get a number for this? What'd you get? Anyone confirm that?
95.67.
Maybe a rounding discrepancy. Yeah, depending on where you round. Like if you never rounded this number, like if you stored this in your calculator, for example, and then plugged it in here, and then also never rounded this one. So you could get them, depending on how precise you want to be, but that's where you're off by 4/10 though. That seems weird. Let me see. Because 4/10 is kind of a big amount. I'm getting 95.66. Hey, did you like never round anywhere?
No, I went with the -4.9. I just switched that 9.8 over.
Well, that wouldn't have any effect. I'm talking about, did you
That was the
maybe
only thing I did. I had 40. Never mind.
just a typo? You had a typo?
Yeah.
Okay, that explains it. That's good. Yeah, a lot of times, guys, what I'm saying is like if you say, instead of 43.3, if you actually typed in 50 sine of 60 there, and then I'm just saying if those were all rounded to say 10 decimal points in the calculator, it shouldn't have a huge effect on this number. You might see a difference of like 100th or maybe a 10th possibly. But anyway, so you should get about 95.66, I think, roughly. Meters, great. So that's the maximum height. C, we already talked about. The answer to C is 25. Make sure you understand that. Are there any questions on that one? Why it's just 25? Okay. And okay, when will the cannonball hit the ground? Yeah, so basically double this time, right? So the time it takes to go to its max is equal to the time it takes to fall back down. So the time to hit the ground, the time at which it hits the ground, is 8.84. In fact, you want to make it clear what you're doing. So for this one, I might just write 2 times 4.42. This way, someone reading your work, someone looking at your explanation can see, oh, that number showed up earlier in the problem, and I can see there's doubling it, and I can see your logic. If you want to be really thorough, you might put a little note of like the time it takes to reach the max height is equal to the time it takes to go from the max height back out to the ground. And then E is how far from the cannon will the cannonball be when it hits the ground? How do we solve that? Now I'm looking at horizontal motion only horizontal. I guess I'm grabbing a time value from the vertical motion, but I'm going to say how fast was I traveling? So I'm going to say something like displacement equals velocity times time. By the way, I can write that because in the horizontal direction, acceleration is 0. Makes sense? Okay. So my velocity was 25 meters per second, and the time was 8.84 seconds. And so we get 221. Point anything? Point 0?
I think I rounded up, so I think.
So if you, oh, it is? Huh, yeah. It would be 0.0 meters. Okay, so if you so just over 2 football fields, it's not far away to go. It's not a crazy distance. So if you did that yesterday after class or at home or whatever, and you got them all right, good job. It means it's probably clicking for you. It probably means you're understanding it at least fairly well. So yeah, let's just take some class time to. I don't have much more to cover with you, honestly. I will go over 24 with you tomorrow. If you want to try, 24 is a good exercise if you're feeling like you're understanding this pretty well and you want to tackle like a challenging question. It involves a computer. So basically you're gonna derive a general formula for how this kind of behaves, like we've been doing, and then figure out what's the ideal angle to shoot something from ground level if you want to maximize the distance it travels. And that's what 24 answers. And then 25, 26, 27, and 28 just use that formula. So anyway, for now, if you just want to like stay on the normal course, just finish through 23. And that's it. That's it for the stream today. Thanks for the 100 bits.